So what we did first is we have a stock solution, right? What we did was just create a dilute, which is going to be really nice when we run this doing absorbance, because if the color is too dark, it actually won't read. So we actually have to, that's the reason why we're doing that to be dilute. So what happens is, once you create your solutions, you can see the concentration of the iron increasing as we go from test tube 1 to test tube 5. Now, because we're using the spec 20s, right, our spec vises, we have to transfer them into the cuvettes, which we use for the alcohol lab. I've gone ahead and done that, and I've also created a blank, which is going to have our dilute ferric nitrate solution, which will allow us to calibrate the graph. So what I'm going to do here, and as you can see, it's about right here, because if there is color, we would see absorbance, because the solution would be absorbing the incident light that we would see. So again, following your directions in the laboratory, we are going to calibrate the spectrometer 1. Here we're going to get the warming up of the lamp. Now the lamp has already been on for a while as we were filming Dr. Nazir's videos. So I'm going to skip the warm up, and then I'm going to take the blank, as you're familiar with, of course, wiping it to make sure we have no smudges, grease, or anything like that. That'll cause the light to scatter, and then will give us a false absorbance reading. So this, once the calibration goes through, should set our absorbance, and you'll see it, to as close to 0 as it can get. And then once I push OK, you see that drop down to 0. Obviously, there's no iron, there's no thiocyanate in the solution. So, and that is why we're not going to see the colored complex, right? Once we start adding, and starting with our most dilute concentration, we will notice our absorbance to start increasing. So I'm going to push collect, and what you'll see is a point come up on your graph, and it's recording the absorbance for that concentration of iron nitrate. So again, this is reading the absorbance of the iron thiocyanate complex that is formed. What I'm going to do is push keep. You've gone ahead and calculated your concentrations. So this one is going to be 0.00001. And we'll push OK. And there I'll have this plot. So this is what's going to create our standard curve. Now mind you, our axes are a little wild right now because our concentration is very dilute. So what I can go ahead and do is change this. Once I'm done with the collection, to see that nice calibration curve. Now I'm going to go on to my next one. This is number 2. Again, the color is getting more intense, darker. The concentration of your iron nitrate is increasing, right? We put 2 mils in this one now. And as you'd expect, absorbance is increasing. So we were at 0.113. Now that there's more in there, more to absorb, we're seeing a higher absorbance. So this is at 0.334. We're going to let this calibrate, kind of equal out, steady off, and then we're going to push keep. And again, we're going to put in our concentration, 0.00002. And that'll keep that there. You're going to keep doing that for the other 3 solutions. When you're finished, we'll stop the collection and go over here to do a linear fit. Now, once I put more lines on this, once I put more plots on here, we'll get a better fit. But we're going to move on to the next portion of this, which is where you're going to be calculating the equilibrium constant for this reaction.